Welcome to Spaceverse, your portal to cosmic adventures. In a cosmos brimming with countless galaxies, swirling, colliding, dancing through space, most live quiet, anonymous lives. They drift in the darkness, invisible to our eyes and hidden from even our most powerful telescopes. But every so often, one makes itself known. It doesn't shout, it doesn't move, it simply shines. Brighter, bolder, and stranger than expected. And just recently, the James Webb Space Telescope caught one of these cosmic showstoppers in action, a galaxy so peculiar, it's rewriting what we thought we knew about the early universe. It's called GSNDG 9422, and it might just help answer one of the biggest questions in astronomy. How did the cosmic story begin? Let's take a journey into deep time to a place nearly 13 billion years in the past. The James Webb Space Telescope has been reshaping how we see the universe. With its ability to peer through cosmic dust and capture light in the infrared spectrum, Webb is giving us access to the ancient history of the cosmos. It's revealing galaxies from the universe's infancy, shedding light, literally, on a period once cloaked in darkness. One of its latest discoveries is GSNDG 9422, a galaxy so distant that it existed roughly 1 billion years after the Big Bang. That might sound like a long time, but in cosmic terms, it's incredibly early, just after the universe's turbulent youth. Now, GSNDG 9422 isn't the flashiest galaxy out there. It's not large like a majestic spiral, and it doesn't dominate the sky. In fact, at first glance, it's fairly inconspicuous. But when scientists looked at its light signature, they knew something was very different. Alex Cameron, an observational astronomer at the University of Oxford, recalls his reaction the first time he saw the galaxy's spectrum. He said, "That's weird," which in the world of astronomy might be one of the best things you can hear. Because weird means new. Weird means unexpected. And in the case of GSNDG 9422, weird meant important. That spectrum, the detailed fingerprint of light coming from the galaxy, didn't match anything astronomers typically see. In fact, it revealed patterns never seen before. The light wasn't coming just from stars. Instead, it looked like something else was at play. So what was going on? A recent paper, published by Cameron and his colleagues in the monthly notices of the Royal Astronomical Society, proposed an explanation: superheated gas. That's right, the unusual light wasn't being produced by the stars alone, but by gas clouds so incredibly hot that they actually outshine the stars themselves. It's an exciting clue. Because when computer models were run simulating gas clouds heated by massive, hot stars, the results were nearly identical to what Webb observed. That kind of match is rare and compelling. It suggests that GSNDG 9422 is a galaxy in the middle of something truly extreme, a massive star-forming event. Astronomers believe the galaxy is undergoing a star birth sprint. Imagine countless stars being born in a frenzy, pouring out intense radiation. That radiation, in turn, slams into the galaxy's reservoirs of gas and dust, heating them up and causing them to emit dazzling light that the JWST managed to detect across space and time. So in a sense, JWST didn't just see a galaxy. It saw the glowing aftermath of star formation on overdrive. A cosmic fireworks show that had been traveling through space for 12 billion years until now. But there's more. The stars responsible for this spectacle aren't just hot. They're scorching. According to the study, the temperatures of the stars in GSNDG 9422 exceed 140,000 degrees Fahrenheit, or around 80,000 degrees Celsius. That's more than twice as hot as what we expect from even the most massive stars in our local universe. Study co-author Harley Katz, an assistant professor of astronomy and astrophysics at the University of Chicago, commented on this, saying, "Makes sense because the early universe was a very different environment." And he's right. In the early days of the universe, everything was more chaotic. The cosmic microwave background had just faded. The first galaxies were just assembling. Matter was still coalescing into the structures we know today. The stars born during this time were likely larger, hotter, and lived faster lives than the stars we see now. And GSNDG 9422 is providing a rare first-hand look at this strange and exciting period. What makes this discovery even more significant is how it might reshape our understanding of galaxy evolution. For years, astronomers have struggled with a puzzling observation. Many galaxies in the early universe, just a few 100 million years after the Big Bang, appear to be fully formed. They were already large, already teeming with stars, and many had well-defined structures. That shouldn't have happened so quickly. At least, not according to older models of galaxy formation. So the discovery of GSNDG 9422 offers a tantalizing clue. Maybe these early galaxies went through brief, intense periods of growth, star-forming sprints that rapidly built up their mass. If GSNDG 9422 is an example of this phase, then astronomers may have found a missing link, a transitional object that connects the dots between the universe's very first stars and the fully structured galaxies that emerged later. By studying more galaxies like this one, scientists can determine just how common or rare these kinds of cosmic events were. And that could help refine our models of how galaxies like the Milky Way came to be. Alex Cameron said it best. It's a very exciting time to be able to use the Webb telescope to explore this time in the universe that was once inaccessible. We are just at the beginning of new discoveries and understanding. And truly, this is only the beginning. With every observation, the James Webb Space Telescope is uncovering galaxies, stars, and structures that challenge our understanding of the cosmos. It's reaching back into a period that had, until recently, remained entirely out of reach. We're now able to witness the cosmic dawn, not just in theory, but with real data, real light, real stories. And GSNDG 9422? It's telling a particularly wild one. A story of gas heated until it glows. Of stars so massive and hot they defy expectations. Of a galaxy pushing the limits of what we thought possible, not by size or mass, but by behavior. And all of this, recorded across a gulf of time so vast, it boggles the imagination. So what comes next? Astronomers will continue observing GSNDG 9422. They'll look for similar galaxies, compare their properties, refine their simulations, and eventually reconstruct a clearer timeline of how the first galaxies emerged. With the power of JWST, that once hidden chapter of the universe's history is now opening page by page, light by light. And each new discovery like this reminds us of just how much we have yet to learn, and how much more awe the cosmos still has in store. If you enjoyed exploring GSNDG 9422 and want more deep dives into the most fascinating discoveries in space, don't forget to like, subscribe, and ring that notification bell so you never miss a journey across the stars. Here on Spaceverse, we're just getting started unraveling the mysteries of the cosmos. Until next time, stay curious and keep looking up.